Hello everyone. Today we will talk about the question 2 of homework 10. Now let's look at the question. The question asks us to collect the definition of the property of those stochastic process. The first one is wide sense stationary process. The definition for this WSS process is like if its mean, FS, the first one, if its mean is a constant and autocorrelation is a function of time difference. We can write this down. Correlation is a function of time difference. And the second process is called independent increment process. Independent increment process. For this one, the definition is xt1 minus xt2 and xt3 minus xt4 on non-overlapping intervals are independent. And the third one is the Markov process. For the definition of Markov process is like if the past has no influence on the future when the present is null. And the fourth one is the normal process. For the normal process, the definition is like a process xt is said to be normal if the random variable xt1, xt2 all the way to the xtn are jointly normal for any n, any t1, t2 all the way to tn. So when we write the equation for the normal process, it looks like this in here. Normal process looks like this. In here, we can write the x as this matrix, and the capital X is this matrix, and the eta is equal to the EX matrix, and the C in here is equal to 2. This part. And the fifth one is the strict sense stationary process. Strict sense stationary process. For this one, the definition is if its statistic is not affected by a shift on the time x-axis, then this process is said to be strict sense stationary process. And the sixth is the white noises. The definition for the white noises is like for Wt, if we wish to discuss its derivative Vt equal to dWt divided by dt, then we have E Vt equal to the d dWt divided by dt and equal to 0, and the Rv T1 T2 is equal to alpha sigma T1 minus T2. And the Wiener process Wt doesn't have the derivative, so we use the Vt equals to dWt divided by dt as the notation. And for the seventh one is the mean ergodic process. The definition for the mean ergodic process is, we can write the equation as this form in here. In the mean square sense. And the eighth one is the martingale. When a stochastic process xt is said to be martingale, and when the ext, this point here, is equal to the x1, for in here the s is less or equal than t. So when we say the process xt is a martingale, then if this equation is satisfied, then we can say this process is martingale. And here is the definition for all these stochastic process. And thanks for listening.